Greetings to the viewer. My name is Janvi Chauhan and I am a student of IIPS DAVV Indore pursuing MTech in IT, currently in 8th semester. This video is made as an internal assignment of the subject Cloud Computing under the guidance of Dr. Vivek Srivastav sir. Topic for this presentation is fog computing. In this presentation, I will be starting with the benefits of cloud computing and also some problems associated with it. Then I will discuss the solution for the problems with cloud, then the deployment overview of the fog computing, along with various roles in it. I also made a comparison between the cloud, edge, and fog computing, and then finally concluding the topic with pros and cons. So let's get started. As we all know, most of today's applications are deployed on top of cloud services, providing cost benefits, ease of use, elastic scalability, and illusion of infinite resources. While cloud services come with these obvious benefits, they also have a major disadvantage. Cloud data centers are centralized and thus typically far from the end user, resulting in high access latencies. This is sufficient for many application domains such as enterprise or web applications, but not sufficient for more of the modern application domains such as autonomous driving, IoT based platforms, or 5G mobile applications, and so many. Therefore, these applications are deployed on edge devices. However, while such edge devices offer low access latencies due to physical proximity to end users, they also come with limited resources and are subject to availability problems. That is why the generation moved towards cloud computing. But then we need to think here that to overcome the disadvantages of cloud, shall we get back to edge computing? In this way, the cycle will go on. To overcome the disadvantages of the one, we will move to the other computing. So, to overcome this situation, an obvious approach is to use both cloud services and edge nodes at the same time to achieve low latency while having access to scalable, infinite resources. This paradigm, which has recently emerged as a natural extension of cloud computing, is typically referred to as fog computing. So, what precisely fog computing is and how can it be distinguished from edge computing? Edge is exclusively about computation at the edge of the network without any notion of the devices, notion of the cloud services. Depending on the source, fog computing is either same as edge computing or is defined as the amalgam of cloud, edge, and any intermediary nodes in between. The figure 1 shows the high level deployment overview of fog computing. Fog computing is more than just creating a data center in the box, that is the cloudlets, to bring cloud closer to the data producers. Instead, fog computing must be seen as a resource layer that fits between the edge devices and the cloud data centers. The goal of fog computing is to provide a set of methods and tools to create a continuum between edge and cloud. For this, fog computing technologies specially need to enable fluid data movement between cloud services and edge in both directions, while satisfying application constraints in terms of quality of service. Such data movement may also be accompanied by a movement of computation both in same way and in a complementary fashion compared to data movement. Talking about the roles in fog computing are as follows. Already, today, cloud services service providers offer access to cloud infrastructure services. Edge service providers may do the same for edge resources. Fog service providers, in contrast, offer service based access to fog infrastructure resources. In this context, fog service providers may act as resellers. Alternatively, we can say two or more of these roles may be held by the same organization. Finally, fog application providers rent resources through fog infrastructure services and offer their application to clients. Here I have drawn a comparison between the fog, cloud, and edge computing. Talking about the location of data processing, where the data is processed, in cloud computing, the data is processed in the central cloud server. In fog computing, data is processed at the fog nodes that we have created, which are located in the LAN network. And in edge computing, the data processing takes place within the device itself on which the services are being used. Purpose of cloud computing is long-term in-depth analysis. For fog and edge computing is the quick analysis and real response time. Talking about the latencies, obviously cloud computing has high access latencies because the data has to travel a lot of distance, while on the other hand, fog computing offers low latency and edge computing offers very low latency as the data is in the user's proximity. Talking about security, cloud computing is less secure because all the data, whether it is sensitive or to be shared, is all with the third party. Fog computing is comparatively secure than cloud as fog computing enables to have sensitive information at the edge and only transmit the required information to the cloud. And similarly, edge computing is highly secure. Geographical distribution for cloud computing, it is centralized, and fog and edge computing are distributed. Moving further, discussing the pros and cons of the fog computing. First, let's consider pros. It reduces the amount of data sent to the cloud because it keeps some of the data to the edge, some to the cloud. So the load at the cloud is reduced. It conserves network bandwidth. It improves system response time. Of course, as we have already discussed, the latency gets reduced. Improves security by keeping data close to the edge. Sensitive data is secured on the edge device itself. It supports mobility and minimizes network and internet latency. Discussing the cons, physical location takes away from anytime, anywhere, any data benefit of cloud because cloud is centralized, but fog is not centralized. It depends on the location of the fog server, like the LAN network where the fog devices are installed. So anytime, anywhere services are affected. There are also some security issues. Like it is secure in terms of saving the sensitive information, but not secure. Like IP address spoofing or man in middle attacks can take place. Like as many things we include, as many chances of attacks increases. There are also privacy issues in it, and also the cost. We have to pay the cost for fog equipment and its hardware to install the servers. Trust and authentication concerns and also wireless network security concerns are associated with it. So at the end, what I have discussed so far is while cloud computing can today be considered well established, modern application domains such as IoT, autonomous driving, or even mobile applications trying to tap the full potential of future 5G networks require an extension of the cloud towards the edge, thus naturally leading to the new fog computing paradigm. In fog computing, application services run on both edge nodes which have low latency access but very limited resource capabilities, and in the cloud with higher access latencies but practically unlimited resources, as well as on possible intermediary nodes. With that, I end my presentation. Thank you so much for listening to me.